See Lindelof videos, particle motion, change in velocity. So we're given this position function. Let me say this to you so I'm being as clear as possible. Please be careful to notate what your professor or what your AP reader is, what function they're giving you. So I'm telling you that this is position. So this is the position function. What the question is for what times t is the velocity of the particle increasing? So when is v increasing? So if velocity is increasing, what we're really looking for is acceleration greater than 0. So we're looking for a of t greater than 0. So all I'm going to do here is I'm going to start taking derivatives. The velocity derivative, v of t, is the same as x prime at t, which is equal to 4t cubed minus 12t. Isn't it? So that's all well and good, but we're interested in acceleration. So we know that the second derivative of position, which is the first derivative of velocity, is acceleration at any time. I'm going to take this derivative, which gives us 12t squared minus 12. Pretty good, right? And we want to know, when is this greater than 0? So I'm just going to set it equal to 0. I'm going to factor out a little bit. I'm going to say, when is 12 times t squared minus 1 equal to 0? That tells us when acceleration is 0. Gives us a place to look from, doesn't it? So from here, that's exactly what my intention is. I don't have to worry about this 12, so I have this. I have t squared is equal to 1. T is equal to plus or minus 1. We don't need to worry about minus 1 because it says clearly here that we're only interested in t such that t is greater than or equal to 0. So we only have this one here. So that's what I'm going to do here is this. I'm just going to take a quick peek here, and I'm going to try to figure out. So I'm going to look here. Say, okay, at 0, excuse me, at 1, a of t is equal to 0. Well, what happens on the other side? So I think what I tested was like 2 or something, because acceleration only changes at those two places, so it's not going to change. It's only changed to the left. It's not going to change again over here on the right. So I'm looking, and I'm going to take maybe, a of 2, and a of 2 is equal to 2 squared is 4 is equal to 36. Well, 36 is positive. I would do the same thing here. I would take a value to the left-hand side. Maybe I take 0. So I took 2. Why 2? Because 2 is an easy value. I need one to the left and one to the right. If I take t of 0, which is to the left of that, which is on our interval, we would get a value of negative 12. So this is negative. So what can we say? We can say that the velocity is increasing where t is greater than 1. All right? So there's our answer. Thanks for watching. If you have any questions or comments, let me know. If you haven't already subscribed, please do. Thanks. Appreciate it.